Good day, viewers. You're welcome again to my YouTube channel, Mathematics Made Easy. Now, in this video, we are going to learn how to prove this Ramanujan famous sum. Srinivas Ramanujan was an Indian mathematician who does not have a formal education in mathematics and the exploit in the field. So he propounded this sum. He said the summation of the natural number is -1/12 from one of his letter. Okay, we have this, but how can we prove that 1 plus 2 plus 3 plus 4 plus 5 plus dot dot to infinity is -1/12? Normal. If we have to do this, maybe in algebra class or your real analysis class, we can just say that this diverges to infinity. But how does Ramanujan finalize that the sum of the natural number is -1/12? So now, there's a lot of videos online on YouTube that explain how Ramanujan arrived at this point that the summation of the natural number is -1/12. But in today's video, I will be using Ramanujan summation. Okay, and then what is the Ramanujan summation formula I will be using? According to Ramanujan, we have f(0)/2 plus summation of n from 1 to infinity, summation of n, so is equal to iota I multiplied by integral from 0 to infinity of f of it minus f of minus it over e raised to the power of 2 by t minus 1 dt. So this is what, or this is the formula we'll be using to find out how Ramanujan arrived at this answer. Okay, so this is Ramanujan summation formula. Okay, now what can we do? We can just introduce an arbitrary function here. So let's introduce f of x. So let f of x be a function. All right, so let f of x be equal to x. Okay, so if f of x is equal to x, now here, that is, if I put 0 here, so this will also be 0. So f of 0 will just be 0. That will be 0/2 plus, okay, summation of n from 1 to infinity of n is equal to iota multiplied by integral from 0 to infinity. Then f of it, if I put it, so that will be it, that will be it minus, and then minus it, so that will be minus it. So over e raised to the power of 2 by t minus 1 dt. Okay, so let's move on. 0/2 is just 0. Okay, 0/2, that was just 0. 0/2 is just 0. So this one is 0 plus a summation of n from 1 to infinity is equal to, it minus this minus that plus. So that will be iota multiplied by 0 to infinity of 2it over 2 over e raised to the power of 2 by t minus 1 dt. Alright, so we can see that 2i multiplied by I, so that will be -2. So this is just summation n from 1 to infinity of n is equal to -2 integral from 0 to infinity of t over 2 by t minus 1 dt. Okay, now let's move on from this point here, from this point. So let's move on. What are we going to have? What are we going to have? What are we going to have from this point? Okay, now since we arrived here, we said summation of n from 1 to infinity of n is equal to minus 2 integral from 0 to infinity of t over e raised by 2 pi t minus 1 dt. So what can we do to solve this particular integral? So I can make a substitution here. So making that substitution, so I can say let 2 pi t be equal to x. So if 2 pi t is equal to x, what will be the value of t? So t will be equal to x over 2 pi. Then the t will be equal to the x over 2 pi. Okay. Then we are going to have summation of n from 1 to infinity of n. So it's equal to minus 2 integral from 0 to infinity. So t is now x over 2 pi. So that will be x over 2 pi. Then the t is now the x over 2 pi over this is now x e raised to the power of x minus 1 dx. Okay, the x is already there. So 2 pi times 2 pi, that is 4 pi. This 2 can cancel 2 out, so that will be 2 pi squared. So then we have minus 1 over 2 pi squared integral from 0 to infinity of x over e raised to the power of x minus 1 dx. You know, from our previous video, I explained the BOSE integral. The BOSE integral. I said if we have integral in this form, you know, this is just this is, I can write this as minus 1 over 2 pi squared integral from 0 to infinity x raised to the power of 2 minus 1 e raised to the power of x minus 1 dx, because 2 minus 1 is just 1, and then we are going to have our x. So from that Boltzmann integral, from that BOSE integral I taught in my previous class, so you know, gamma of s multiplied by the zeta of s is equal to integral from 0 to infinity of x raised to the power of s minus 1 over e raised to the power of x minus 1 dx. So our s here is 2. Okay, so this will just be minus 1 over 2 pi squared multiplied by gamma of 2 multiplied by zeta of 2. Okay, so we have that. Let's finalize the solution here. So that will be equal to minus 1 over 2 pi squared. So gamma of 2 is just, you know, if we have gamma of x is equal to x minus 1 factorial. So gamma of 2 is equal to 2 minus 1 factorial, which is 1 factorial, which is equal to 1. So that will be 1 multiplied by zeta of 2. And then what is zeta of 2? Zeta of 2 is just pi squared over 6. So this will be equal to minus 1 over 2 pi squared into bracket pi squared over 6. So pi squared cancel pi squared. They have minus 1 over 12. So we arrived at the answer using a Ramanujan formula. So please don't forget to subscribe to my channel. Don't forget to like my videos, share my videos, and comment. God bless you. Goodbye.